I'm Saul Reisman here at Saul's Automotive, and today we're going to talk a little bit about the modern Jeep. Now, the Jeep that we know was built in World War II, was designed to be small, lightweight, indestructible, off-road capable, and that was its only intentions. Fast forward 70 years, and the same technology is still being applied to these modern vehicles from an off-road prowess standpoint. However, a lot of the engineering aspects have changed to fit modern civilization and keep the mom-and-pop owners happy and safe. As a result, some of the off-road performance aspects have suffered a little bit and need some addressing. In the case of this 2011 Jeep Wrangler Rubicon Unlimited 4-door, the most popular Chrysler product sold in the world at this moment. The vehicle itself came from the factory with locking differentials, a disconnecting front sway bar, solid beam axles, 31-inch tires, skid plates, was a pretty fairly capable off-road machine. However, Jeep Chrysler Corporation built this vehicle stronger than its actual running gear and undercarriage components could handle. The frame of the vehicle was truly designed for the off-road enthusiast who wanted to modify their vehicle. They want to make it bigger, wider, taller, larger in every way. While that is very beneficial for people like myself, or possibly you who want to make your Jeep bigger, better in every possible shape you can, it also made it a little difficult for some of those that purchased these vehicles new and assumed they were as capable as they once were. In the case of this vehicle, we're going to take a look at the few components that got damaged when it went out for some serious off-roading. While the body remains intact, the motor and transmission did survive. Basically every drivetrain component has been broken. While we go through these, we'll be showing you a few different ways that we can improve and upgrade these so that you can keep yours on the road longer, safer, and wheel it in harder places. We're going to start by taking a look at the front differential for the vehicle. Inside the front axle assembly, which we currently have completely stripped down, the front differential carrier resides in the center. Where this pinion gear rotates from the drive shaft, the carrier sits in two bearing halves to rotate and spin both axle shafts. We have both these axle shafts present on the ground in front of us. They engage on splines where they slide into this carrier. Now, in the case of this vehicle, the axle shafts then pass through the knuckles themselves, which is what steer the vehicle side to side. In this pocket, that shaft must bend and twist. As a result, there are U-joints, a universal orbital joint that we would typically see in a drive shaft or similar configuration to allow rotational motion. However, these U-joints are essentially a torque limiting fuse. They're designed to break under high stress so that other drivetrain components do not fail. However, the design in which they fail actually causes other seriously detrimental damage. In the case of this vehicle, both front axle shafts snapped in half, both front U-joints were ruptured, and when this happened, the bearing caps that used to reside here were shattered off of the axle shaft itself, rendering this axle shaft completely useless. So, while the U-joint did break and operate as a fuse like it should have, it still caused $1,000 in damaged parts on the way. So to prevent this from happening in the future, we're going to be installing Ox brand U-joints, which are guaranteed for the life of the vehicle, parts and labor. Additionally, we're going to be installing chromoly 4340 steel alloy axle shafts. These axle shafts themselves are 40% stronger than the factory shafts, and rather than a factory shaft that would simply crack like a cinder block hitting the ground because it is brittle, these are built from a more durable material that will actually bend like a bumper might if you were to hit it in a car accident. As a result, in the event of a serious calamity like a U-joint failing, when that U-joint ruptures, rather than breaking the corners off that axle shaft and rendering those ears useless and unserviceable, the U-joint will still fail, but the U-joint straps, those caps themselves, may bend a small amount and will be reshapeable, reusable for the life of the vehicle. Not only will this allow a stronger U-joint to be used, increasing that fuse limit and decreasing the frequency of them breaking, but this allows them to be serviceable throughout the life of the vehicle. Now, the reason that axle shaft broke is even more entertaining. So the way a differential works is it differentiates from one side to the other for power distribution. By the nature of having one input shaft and two output shafts, torque must take the path of least resistance. If power has the option to push uphill or push downhill, it will push downhill. If one tire is on dry pavement and one tire is in water, the tire that is in water will spin and the one on dry pavement will not, rendering even a true four-wheel drive vehicle not very capable in that type of situation. Additionally, when torque transfers from one side of the vehicle to the other, very violent forces occur on those U-joints. In this case, that's what caused both front axle shafts to get broken. Because this vehicle is in the air with the front tires rotating, when it came into contact with the ground and that static traction load, that coefficient of friction suddenly applied to both those sides, ruptured both U-joints, tried to transfer that power across, and broke both those axle shafts. To stop that from happening in the future and to help ensure positive traction from both front wheels, we're installing a lock-right locking differential. Inside this rotating carrier that the ring gear bolts to, we've actually installed a small device that's a spring-loaded, quad clutch pack driven pin. And what this will do is, instead of letting these two outer gears rotate in opposite directions freely to let torque differentiate on its own, these two clutch packs, which are being forced apart with almost 1,000 pounds of force, will act as a spring clutch, and in the event of power being distributed into them, will distribute power both directions by forcing these gears apart. However, because there's a spring in here, in the event of a tremendous amount of load being applied to it, these springs will give in and let it still ratchet or differentiate as it should. What that translates to is, because this is in the front of the vehicle, if the vehicle were on dry pavement in four-wheel drive with this device installed and tried to make a sharp turn, both front tires must spin at the same rate at the same time, no matter what. We know from watching a vehicle's path through the dirt as it curves that the outer tire must physically travel a greater distance and therefore at a higher velocity than the inner tire. This simply isn't possible with the locking differential. So as a result, by building it with an internal spring clutch pack, it allows the vehicle to ratchet freely in hard corners, so that when going in a straight line, the vehicle will lock up, both front tires will get power, 50%, 50%, no matter what. But in a hard corner, when throttle's applied and tremendous force goes on this differential, it'll still open up and allow it to move smoothly and therefore safely for a regular driver. This way you can rest assured that not only are you getting more traction to the ground, but you're doing it safely and in a way that won't damage other components. By using a locking differential like this, we're able to guarantee that both those axle shafts get an equal load at all times. Installing this will not only increase the amount of traction the vehicle is getting to the ground, but will decrease the likelihood of further component failures. So, we're going to be installing this lock-right locking differential, Alloy USA 4340 chrome moly axle shafts, and Ox U-joints into this front axle to essentially make it as bulletproof as it can be. The next logical upgrade will be physically removing and replacing the entire axle assembly itself. While that is something that can cost $4,000, $5,000, $6,000 or more, these kind of components can be installed one at a time, are cost-effective, and typically significantly less expensive than complete axle swaps. If you have any concerns about the front axle in your Jeep and how to best get the most power and reliability out of it, how to keep the strength in it, please give us a call here at Saul's Automotive. We would be happy to show you the current condition of it, how we can help you, what possible upgrades are out there, and how to plan your budget accordingly so that you get the vehicle you want for the price you deserve. Please give us a call at 303-919-7769. Thank you.